Hi guys, welcome back to organic chemistry. We'll look in this lecture a small part of organic chemistry. It's extremely important. Aromaticity is a question. Aromaticity is embedded in organic chemistry, particularly carbocation stability, all those things. Okay, so I'm going to do this as a separate lecture so that it's easy for you guys. As always, na notes group la anupchitten. It's also posted in Google Classroom so that you don't have to draw anything. Just write down the key points that is not printed in the notes, or you may want to write it in your own words. Let's start the lecture. Now, what is aromaticity? It's basically a property of cyclic planar structures. So, they have told you two things. One is cyclic, the other one is planar. Both of them are extremely important for you. So, acyclic compounds aromaticity na cyclic compounds. So, you want to be sure of that. And second thing you want to be sure is it has to be planar. Ena non-planar irundhudu appadina ungalala resonance poda mudiyadhu. Okay, so you want a planar structure, and that is cyclic, with obviously pi bonds in resonance with each other, delocalized electron. So resonance na thaniya or chapter na poda poren. At this point, what you want to know as resonance is alternate single and double bonds. Okay, alternate single and double bonds. Example inge benzene kuduthirken, double single double single double single. So alternate single and double bonds. Now in aromaticity, just because you have alternate single and double bonds does not make it aromatic. Okay, what you want to know is alternate single and double bond irukkanum, and because of that it has to give increased stability compared to other possibilities. What it means is, look at this one, both of them are C6, alternate single and double bonds, but in the configuration more stable. Only in those cases you call them aromatic. Even though in some cases you will have alternate and single and double bonds, you cannot form aromatic compounds because open chain or closed chain stable irukadu. We are going to see that. Aromatic occasionally refers informally to benzene derivatives, meaning aromatic compounds nale benzene ring compound அப்படினா பாப்பாங்க. அது informally, occasionally, it's not always true. Okay, there are a lot of compounds that are non-benzene compounds, but they are aromatic. We are going to see them as well. Aroma na smell. So once upon a time it used to be thought that anything that has benzene ring has smell, so it is aromatic, but now you want to know not all aromatic compounds have smell. So that obviously in the definition of aroma, the root not all of them have smell, and not all of them are benzene derivatives. Many non-benzene aromatic compounds exist, and another thing that you want to know in terms of NEET is aromatic functional group on the aryl. For example, so let's say we have this. Okay, this group is called aryl group. The compound is aromatic compound, but the main group is not the aromatic group, it is actually the double bond. Okay, so it is an aryl group. Now more specifically here it is a phenyl. So what is making a compound aromatic? So you need to form a set of conditions for the aromatic compound to obey. What are those conditions? நீங்க இந்த ஞாபகம் வச்சுக்கணும் கண்டிப்பா. நாலு எக்ஸாம்பிள் கொடுத்து எது aromatic இல்ல எது aromatic இல்லன்னு கேட்டாங்கன்னா you have to go through all four of them. First one is a delocalized conjugated pi system. இங்க இருக்கிற மாதிரி alternate single and double bonds, most commonly an arrangement of alternating single and double bonds. உங்களுக்கு இதுதான் வரணும். Most commonly வேற மாதிரி இருக்கலாம், but உங்களுக்கு அது கிடையாது. So you want to look at alternating single and double bonds. Okay, just because you have alternate single and double bond doesn't mean that it is going to be aromatic. It has to be coplanar, meaning ஒரே plane la irukanum with all contributing atoms in same plane. See here I have 6 contributing atoms. Benzene la irukra 6 carbon varanjirukken. They are on the same plane and the orbitals are on the same plane. Contributing atoms arranged in one or more rings. So ஒரு ringக்கு மேலேயும் இருக்கலாம் contributing atom. We are going to see those examples later, naphthalene, anthracene, all those. One point I want to make here is all these aromatic compounds, okay, they will have sp2 hybridization for you guys. Okay, உங்களுக்கு sp2 hybridization ஆகும், meaning ஒரு p orbital sp2 na p3 இருக்குல 3 p orbital ஒரு p orbital free இருக்கும். That is the one that is taking part in aromaticity. The empty p orbital that is not taking part in hybridization, resonanceல இருக்கும் ஆனா hybridizationல இருக்காது. You will understand this particular wording when we go to chemical bonding. Okay, at this point at least sp2 னு சொன்னா ஒரு p காமனா இருக்கலாம், அந்த p வேக்கண்டா இருக்கும், அந்த vacancy தான் வந்து actually ends up getting into aromaticity. Most important thing is there has to be 4n plus 2 number of delocalized pi electrons. n வந்து ஒரு integer தான், 0 ல இருந்து என்னவா வேணா இருக்கலாம். So n equals 0 போட்டா 4 times 0 is 0 plus 2 is 2. So here we can actually look into what are the combinations for aromaticity. Total number of pi electrons எவ்வளவா இருக்கலாம். n equals 0 னா 4n plus 2 என்னவா இருக்கலாம். This is going to be 2, 6, 10, 14. So these are the numbers you're going to see, alternate even numbers. Okay, not all even numbers, alternate even numbers will lead to aromaticity. This is electrons, not bonds. Okay, not bonds. Bonds ஆ பார்த்தோம் அப்படின்னா ரெண்டு எலக்ட்ரான் ஒரு பாண்ட் கொடுக்கறனால total number of bonds, double bond will be 1, 3 as in case of benzene, 1, 2, 3, 5 naphthalene, okay, 7, so on and so forth. Now when you have multiple rings, okay, those are, we are going to see them later, those are polycyclic. Now same ring la vandu you can have, the ring has how many carbons that have sp2 hybridized, 1, 2, 3, 4, 5, 6. So ஒரு ringல alternate single and double bond இருந்ததுனா அது பேர் annuline. Annuline. In the annuline, okay, in this annuline, if there is 6 of them, it's called 6 annuline. So as I said, annuline means alternate single and double bonds. நம்ம benzene பார்த்தோம். Okay, now what about aromaticity in larger annuline? So smaller annuline, I want to make a case here. For example, benzene வந்து, we saw this, n equals 1, 4n plus 2 na, you get 6 pi electrons. What about n equals 0? n equals 0 வச்சு உங்களால ஒரு ring வரைய முடியுமானா, this is the smallest ring, correct? Cyclopropane தான் smallest ring, அதில் ஒரு double bond போடலாம். Is this aromatic? No, because alternate single and double bond இல்லை, double single single இருக்கு. So no, we will get back to this later. Now let's go to higher analog. Okay, now here for example 1, 2, 3, 4, 5. So there is 5 double bonds mean 10 pi electrons. Okay, so n equals 4, 2n plus 2 na 10. Okay, now here you want to be very careful. This particular one you have to be very careful. So நம்ம இது வந்து 6 pi electron, நம்ம alternate numbers தான், even numbers தான் பார்த்தோம். 2 not possible as of yet, 6, 8 கிடையாது, 10, 14. So 2 annuline, 6 annuline is benzene, 10 annuline, 14 annuline we can see, and then 14 க்கு அப்புறம் 16 கிடையாது, 18 annuline we are going to see here. Now when it comes to 10, you want to look at this, all of them are cis na இப்படி தான் இருக்கும் ring, all are cis, but not aromatic because இந்த மாதிரி configurationல கொண்டு வரது கஷ்டமா இருக்கும். See, remember we saw cis and trans isomerism, அதில் வந்து உங்களுக்கு அந்த ரிங்கில் வந்து பெண்ட் ஆக ஆரம்பிக்கும், ட்ரான்ஸ்ஃபர் ஆரம்பிக்கும். ஸோ ஆல் சிஸ்ஸாக போட்டால் ring is strained. So it obeys the 4n plus 2 rule. Number 4n plus 2 இருக்கு, but not aromatic because it is too strained. So it is not going to be possible here. So you want to remember this particular example. அதே ட்ரான்ஸாக போனீங்கன்னா 2 trans, இங்கேயும் ஒரு trans, இங்கேயும் ஒரு trans. So the ring is stable. Alright, the ring is stable, but the problem here, what's the problem with this one? Yes, it is not in plane, so it is also non-aromatic. Okay, it's not aromatic because of strain. This is not aromatic because not planar, even though the rules are obeyed. So இது ஒரு exception, you want to remember that. But luckily only one exception, when you go to 14 annuline, this is perfect. So now இந்த காம்பவுண்டை கொடுத்து உங்களை வந்து ஸ்ட்ரெயிட் ஃபார்வர்டாக அரோமேட்டிக்காக இல்லையான்னு கேட்டால் எப்படி பார்க்கணும்னா, இது பிளேனாக இருக்குது. 1, 2, 3, 4, 5, 6, 7. 7 means 14 pi electrons, 14 comes under here, so it is going to be aromatic. Similarly 18. Now here I have actually, what I am showing you here is trans cis. இது அவ்வளோ இம்பார்ட்டன்ட் இல்லை நீட்டுக்கு, பட் அட்லீஸ்ட் ஜியாமெட்ரிக்கல் ஐசோமரிசம்க்கு யூஸ்ஃபுல் இது. வாட் இஸ் தி கான்ஃபிகரேஷன் அரவுண்ட் திஸ் டபுள் பாண்ட்? ஹைட்ரஜன் இங்கே இருக்குது, ஹைட்ரஜன் இங்கே இருக்குது, ஸோ cis. What about this double bond? Hydrogen is here, hydrogen is here, trans. Hydrogen is here, hydrogen is here, trans. It is cis. So you're going to have trans, trans, cis. Trans. In the பக்கம் அதே மாதிரி you can actually have the same here. So this is not that important, but why this is here is this configuration is the reason why this exists and becomes stable. It obeys 4n plus 2, it is planar. Usually இந்த higher order வந்து நீட்டில் வராது, JEE மெயின்ஸில் தான் வரும். But now that it is organized by NTA, you want to be very clear about all this concept. So hence, let's not risk it. Now that we have seen aromatic, we will go into the next one, anti-aromatic. So why anti-aromatic is important is, remember we saw even numberல என்னெல்லாம் இருக்கலாம். Let's write the number itself. 2, 4, 6, 8, 10, 12, okay, 14. Now what are aromatic? 2 is aromatic, 6 is aromatic, 10 is aromatic, 14 aromatic. So what about these numbers? The alternate even numbers that are not coming under aromatic. They are anti-aromatic. Not all of them, but that's how they are going to be. What that does is, and the aromatic கொடுத்த 3 condition, resonance இருக்கணும், okay, it has to be in resonance, and then also you want it, you can go and read it, you want it to be planar, alright, and pi overlap இருக்கணும், but it has not 4n plus 2, it has 4n pi electron. That's the major difference. It has 4n pi electron. If it has 4n pi electron, it becomes anti-aromatic. Why do we call it anti-aromatic and non-aromatic? Okay, so we can take it as 3 types: non-aromatic, aromatic, anti-aromatic. Aromatic is very simple. Non-aromatic na aromatic illana non-aromatic. Then what is this anti-aromatic? Basically what happens is, for a given configuration and a given compound, we saw before for benzene, this is less stable compared to benzene. So on the non-aromatic form order, in the form very stable. In anti-aromatic, that form right there is less stable than the open chain. So in the case la vandu aromatic la vandu open chain vandu less stable compared to close to chain. Anti-aromatic la the open chain is more stable than close to chain because of steric reason, many reasons, okay. So here that is what is anti-aromatic, and you want to be able to say that it has 4n pi electron. It gives decreased stability compared to other geometric arrangement. Previous case la enna pathom aromatic ku idu increased nu pathom, inga decreased. First example and the most important example for you guys is butadiene in a cyclic form. Cyclopentadienyl. That's this. This is cyclic compound. Rende irukku. So 4 pi electrons. Okay, and how many carbons? 4 carbons. Hence it is 4 annulene. Okay. Similarly here, 1, 2, 3, 4. 4 means 8 pi electrons. 1, 2, 3, 4, 5, 6. 6 means 12 pi electrons. Alright, so 6 pi is aromatic, 10 pi is aromatic, 8 and 12 are anti-aromatic. That's all. We saw in aromatic compounds, larger annulenes with 4n plus 2 electrons show aromaticity, except previous slide la paathom 5 double bond இருந்தா மட்டும் cis configuration la முடியாது, and also trans doesn't. But here large ring annulenes 4n system do not show anti-aromaticity. So very simple, inga வந்து large-ஆ போனாலே do not show anti-aromaticity. Extremely simple. So you don't have to even worry about it. Only this configuration you have to worry. These I don't have to worry. They will not be anti-aromatic because just in our previous slide, what did we see? Here right there we saw this is going to be, what did we say here? This is going to be not planar. The same thing we are going to see here. here we are going to have the same problem that these are not planar. This is a tub shape, tub மாதிரி இருக்கும் பார்க்க. So what is the condition for aromaticity and non-aromaticity? First இந்த மூணு கண்டிஷனில் ஒன்று என்ன, பிளேனராக இருக்கணும். So it is not planar. So largeனு போனாலே இது எல்லாமே non-planar. So you don't have to worry, these are all anti-aromatic. கிடையாது. These are all. Then what do they come under? They are not aromatic. Even though they are foreign, they are not anti-aromatic. So these are non-aromatic. That's what they come under. So again we have three things: non-aromatic, aromatic, anti-aromatic. So anti-aromaticல உங்களுக்கு முக்கியமான ரெண்டே example தான். One is this. The other one we are going to see soon. Here is a summary. So is it cyclic? So aromatic, anti-aromatic first மூணு கண்டிஷன் obey ஆகணும்னு சொன்னேன். இது மூணுத்துல ஏதாவது ஒன்று obey ஆகலைன்னா non-aromatic மாறிடும். So cyclic இருக்கணும். Okay. Completely conjugated system of p orbitals, alternate single and double bonds இருக்கணும். planar இருக்கணும். Correct? So in these, what is the option that was violated in these three? It was the planarity. எல்லாத்தையும் alternate single and double bond cycle இருந்தது, ஆனால் planarity problem இருந்தது. Okay, hence those are non-aromatic. So these three are obeyed. You go to 4n plus 2 or 4n. That will tell you aromatic or non-aromatic. Examples is the best way to clear your doubts in organic chemistry. We will do them later. I'll send them worksheet as well and quiz as well. Now, a special case is heterocyclic aromatic compounds. These are in your syllabus. Heterocyclic aromatic compound, very simple. Organic compounds. We are talking about organic compounds. So, organic compounds with rings containing carbon and other element also. Okay, most commonly in the element nitrogen, oxygen, sulfur are they can be also aromatic if they follow Huckel's rule. To follow Huckel's rule, they can use sometimes the lone pairs to make aromaticity happen. Alright, so now let's look at the given examples. Let's go for 4n plus 2. 4n plus 2 la ennalam paathom? 2, 6, 10, 14. We don't have to go that far. We want to look at 6 here. See, 2, 2, 2. One double bond means 2 electrons. So 6 pi electrons. Good. Here I have only 2 and 2. So I can use one lone pair here. So 2 plus 2 plus 2 lone pair electrons. Here oxygen la rendu lone pair irukku. One of them is used and 2 and 2. Same with sulfur. So I can use the lone pair, whereas in pyridine I don't use the lone pair. தேவையில்லை எனக்கு, ஏன்னா ரெண்டு இருக்கனால எனக்கு 6 இருக்கு. So I don't want to use. This is going to be an important thing in your NEET exam, where which aromatic compound, particularly heterocyclic, the lone pair is used and lone pair is not used. If the lone pair is used, in such case the atom donating lone pair becomes less basic. Okay, inga lone pair use ஆகாதனால pyridine is basic, whereas pyrrole is less basic. This is extremely important. Basicity order கேட்பாங்க. Pyrrole is less basic because it is not given away. இதை நம்ம வெளியில கொடுக்கிறது பேர் தான் basicity. We are going to see that basicity later. Okay, separate lecture we are going to talk about it. In inductive and resonance effect we will actually talk about basicity. At this point what you want to know is, இந்த lone pair கொடுக்க முடிஞ்சா basic, கொடுக்க முடியலனா less basic. Okay, I put purine here because purine is actually you are going to see later, purine and pyrimidine bases that you are going to see. Now in this purine, if you see 2, 4, 6, 7, 8, I need 2 more. So this nitrogen can donate a lone pair. So this nitrogen is going to donate. So it is going to be aromatic. Now we can actually talk about an important point here. Lone pair donate panna less basic. So the nitrogen 7, 1, 7 and 3 are basic or more basic. ஏன்னா அந்த lone pair தேவைப்படல. The lone pair on nitrogen 9 is used for resonance, so nitrogen 9 is going to be less basic. They might give you A, B, C, D and ask you which is the most basic or not. That part, is the most basic or not, don't not worry about it now. It will become clear to you when we actually see inductive and resonance effect. Okay, here they have to be in the same plane. So look here, I have drawn pyrrole here. 1, 2, 3, 4 carbons, 2 double bonds are present. Okay, if you want me to draw double bond, it would be right here 1 double bond, right here 1 double bond, and nitrogen's lone pair is taking part in resonance. and here in such case atom containing lone pair becomes less basic. Pyrimidine base பின்னாடி பார்க்க போறோம். Now you can see these are basic. எதனாலனா தேவைப்படல இந்த ரெண்டு எலக்ட்ரான் எனக்கு ரெசனன்ஸ்க்கு 2 4 6. So I have 6 pi electrons. I don't need these. Whereas when I go to imidazole, I have 2 4 pi electrons. I need 2 more pi electrons or a lone pair. So I use this. So இது நான் இங்க ரெசனன்ஸ்க்கு யூஸ் பண்ணிக்கிறனால என்னால வெளியில கொடுக்க முடியாது. So this becomes less basic or not basic. This I am not using, so it becomes more basic. Now why I cannot give this? I can give this. Or why I cannot use this for resonance? This we will see it in resonating structures and also inductive resonance effect. Alternate single and double bond இருக்கணும். We will see that. Okay, let's go to special cases right now. This is important. இதை நீங்க எதுவுமே வரைய போறதில்ல. This is just for understanding. You want to just remember this structure. That's all. Remember this structure and remember this structure. Now here if you see cyclopentadiene, so how will it be? This is how cyclopentadiene would be. Okay, this is how it's going to be. Now this is 2 plus 2 4 pi electrons. So how can we classify this molecule? Alternate single and double bond இருக்கனா இல்ல ரெண்டு single bond பக்கத்துல இருக்கு. So this is anti-aromatic. It's cyclic but anti-aromatic. Sorry. How do you classify this one? Cyclic. Do you have alternate single and double bond? No, I have single and single here. So this is going to be non-aromatic. Okay, so this is non-aromatic. Whereas when I go here, what I can do is, there is a hydrogen here. Okay, I can take this electron and go let the hydrogen go as H plus. You will get this. So I get these 2 electrons and the bond la 2 electron inga vandrum. So 2 2 and 2. So you can draw resonating structures. We will see resonating structures later. At this point just remember this. So I have 4n plus 2 and it is cyclic and coplanar. So this is going to be aromatic. Now what I can do, the same cyclopentadiene, if there is hydrogen, I can take this electron here and let the hydrogen go. You get this. So what do you call that hydrogen is? Acidic hydrogen. In a H plus podula, acid mari podula. So this is acidic hydrogen. The same compound, I can have a different substituent than hydrogen. I can have chlorine. Now when chlorine goes, chlorine is more electronegative. It will take the electron and go. If it takes the electron and go, what happens? It becomes positive. That's what this is. Now what I have? Do I have alternate single and double bond? You don't need alternate single and double bond. நம்ம conjugation இருக்கணும். So ஒரு plus sign or minus sign or conjugation இருந்தாலே போதும். So again what you want is double single sign. Double single positive sign. So it is conjugation and it is planar. Okay, it is planar. What is the number of pi electron? 2 plus 2 4. So it is going to be anti-aromatic. Okay, you don't have to remember all this. They are not going to make you draw the structures. Just know that cyclopentadiene is non-aromatic. Cyclopentadiene anion is aromatic. Cation is anti-aromatic. That's all. One other case we are going to see, it's very similar to this. It is just for your reference. Okay, anyways, what this means is, ஏன் இது anti-aromaticனு சொல்கிறோன்னா அதோட ஓப்பன் செயின் இஸ் ஸ்டேபிள். இங்கே வந்து ஸ்டெரிக் ஸ்ட்ரெயின் இருக்கும். You don't need to worry about it that much. The next one we are going to see is, look at this. This is 7-membered ring, extremely important. 7-membered ring. What happens is, when you have the corresponding compound, okay, this has 4n plus 2 pi electron. Okay, this is cyclic, but it is not aromatic. Why? Because I'm missing resonance, conjugation illa, single பக்கத்து பக்கத்துல இருக்கு. That's the fastest way to know. பக்கத்து பக்கத்துல single bond இருக்கு, so you cannot have. So this cannot. So how do I bring in resonance? இங்க ஒரு charge வந்தா resonance will come. But if I bring a negative charge, what happens? Extra electron இருக்கும்ல, அப்போ 4n plus 2 போயிடும். So I bring a positive charge by losing the hydrogen, acidic hydrogen. இந்த hydrogen lose பண்ணா I get 4n plus 2. So this is extremely stable carbocation because of so many resonating structures. Okay. Now if you see resonating structures, how many carbons are there? 1, 2, 3, 4, 5, 6, 7. And you see 1, 2, 3, 4, 5, 6, 7. Each carbon gets a positive charge shared. Okay. Hence it is going to be aromatic. This is called a tropylium ion. It is going to be aromatic. If suppose இந்த இடத்துல chlorine இருக்கு, போன கேஸ் மாதிரி chlorine போயிட்டு negative charge கொடுத்துட்டு போயிட்டா 2, 4, 6, 8 and it is planar. It is going to be anti-aromatic. This is called a cycloheptadienyl cation, is also called a tropylium ion. We will see this later. Okay. In our case, because it is cyclic and it becomes aromatic, it is more stable than the open chain. The last one we are going to see among these cyclic ones are cyclooctatetraene. So இதை பார்க்கும்போதே என்ன தெரியும் உங்களுக்கு? It's cyclic. Correct? It's cyclic, but it is not going to be aromatic. The reason, it is not going to be in plane. Okay, it's not going to be in plane. Okay, it will be in the tub conformation. So it is not aromatic. Whereas 1, 2, 3, 4 double bonds அப்படின்னா மொத்தம் எவ்வளோ pi electrons இருக்கு? There is going to be 8. 8 is anti-aromatic, but in the compound anti-aromatic இல்லைன்னு நம்ம சொல்லிட்டோம் because it is going to be not planar shaped. But I can make the 8 go into 2 plus na என்னவா இருக்கும்? 8 goes to 2 plus means 6 right there. Okay, 6. So 6 is Huckel's rule, alternate single and double bond arrangement including charges. So this is going to be aromatic. So dication is planar and aromatic. Dianion is 10 pi electrons. This is also aromatic. So you want to remember, இதில் 8 இருக்கும், இது non-aromatic, not anti-aromatic. Okay, anti-aromatic கிடையாது, ஏன்னா planarity கிடையாது, non-aromatic. அதில் 2 electron போட்டாலோ இல்லை எடுத்தாலோ it becomes aromatic. Okay. Now summary. So basically what we have seen before. What is the easiest one? N equals 0, 2 pi electrons. Cyclopropynyl. This is the compound I introduced to you before. Cyclopropene. Cyclopropene is non-aromatic. எதனாலனா planar, ring இருக்கு, 4n plus 2 obey பண்ணது, but it does not have conjugation. There is 2 double bonds here, single bonds here. So to make it into conjugation, I want to make it into a charge. So I can make it 2 charges. ஒன்று இப்படி கொண்டு வரலாம், இல்லை ஒன்று இப்படி கொண்டு வரலாம். How do you get them? இது chlorine இருக்கலாம், this can give you this. Similarly, இது hydrogen இருக்கலாம், this can give you this. Alright, so now this is going to be how many pi electrons? This is going to be 2 pi electrons. So 2 comes under aromatic. So I'm good. So this is going to be very easy for the chlorine to leave. Again, anywhere you form a positive charge, chlorine is leaving, means chlorine goes as Cl minus. This will give a test for chlorine atoms using AgNO3. So when you have, let's say, carbon, chlorine, carbon is something, AgNO3, it gives a test for AgCl white precipitate, means it gives Cl minus. But Cl minus போதுனா அப்ப என்ன கிடைக்குதுன்னு அர்த்தம்? That carbon plus. Why do you get the carbon plus? Because it gives aromaticity, right, in this case. So இங்கே போகும்போது 2 இருந்தது 4 pi electron மாறுது. So it is going to be anti-aromatic, same as this one we saw. This one also we saw. So it's just a summary of what we have seen so far. And we also saw these. Okay, this is just for you guys to have a look at it. Okay, heterocyclic atoms as well. Now in the heterocyclic atom, here the lone pair is not used. Here it is used for aromaticity. We saw this as well. 10 pi system also we saw. Now here I am introducing this, I will talk about it in a minute, naphthalene and azulene. This one, if you see, count the number of atoms, it is 9. Okay, this one, but it is aromatic. 9, 2, 4, 6, 8, 9, 10 pi electrons, so good. It is 8. Okay, now logic use பண்ணி பார்த்தீங்கன்னா 8 மாதிரி ரிங் இருந்ததுன்னா 2 charge இருக்கணும், 9 மாதிரி இருந்தால் ஒரு சார்ஜ் போதுன்னு. ஆர் யூ கேன் ஜஸ்ட் லுக் அட் இட், யூ டோன்ட் ஹேவ் டு மெமரைஸ் எனி ஆஃப் தம். இது எதுவுமே நீங்கள் மெமரைஸ் பண்ண வேண்டாம், ப்ராக்டிஸ்லேயே கொண்டு வந்துடலாம் இதை. பர்டிகுலர்லி தீஸ் திங்ஸ் டோன்ட் ஈவன் ஒரி, கொடுத்த எக்ஸாம்பிள் நம்ம வரைஞ்சிக்கலாம். ஃபியூஸ்ட் அரோமேட்டிக் அண்ட் பாலிசைக்ளிக், வாட் இட் மீன்ஸ் இஸ் மோர் தென் ஒரு ரிங் வந்து ஃபியூஸ் ஆயிருக்கு, ஒன்னோட ஒன்று மீனிங் ஒட்டி இருக்கு. ஓகே, தட்ஸ் வாட் இட் மீன்ஸ் ஃபியூஸ் அரோமேட்டிக். See, there are multiple ways. This is naphthalene you want to remember, anthracene you want to remember. Photanthracene not that important. These two are important for you. Now understand naphthalene on the how many types, we'll just review a little bit. How many types of different positions are there? Electrophilic aromatic substitution lam pinnadi pannanom appadina. Okay, if you want to put one chlorine, how many positions are possible? 1, 4, 5 and 8 are same. 2, 3, 7 and 6 are same because it has plane of symmetry. Okay, we saw this in last lecture. அதே மாதிரி இங்கே பார்த்தீங்க அப்படின்னா 1, 4, 8 and 5 are same. So this and this are same. 7, 6, 2 and 3 are same. 9 and 10 are same. There is plane of symmetry here, plane of symmetry here. You can rotate. Here it's going to be completely different. இங்கே பார்க்கணும் அப்படின்னா okay, 4 and 5 are same. 9 and 10 are same. 1 and 8 are same, 2 and 7 are same, 3 and 6 are same, but they won't give you photanthracene. There is a plane of rotation here. Okay, now a little bit to confuse you, obviously it's chemistry, it's never going to be easy. 4n plus 2 is aromatic. 4n here, 1, 2, 3, 4, 5, 6, 7, 8. 8 double bonds. Correct? That means 16 electrons, right? Pi electrons. 2, 4, 6. So let's strike it out. 2, 4, 6, 8, 10, 12, 14, 16. Now let's do aromatic. 2, 4, 6, 8, 10, 12, 14, 16, 18. Aromatic என்னெல்லாம் இருக்கலாம்? This is aromatic. What are the other ones? Non-aromatic. Here I have 16 electrons, but it is aromatic. Different type of aromaticity, rings full of fuse ainda. Okay, how do I know which ones are looking like anti-aromatic but actually aromatic? Remember only this example, pyrene. That's all you need. Adum JEE la dhaan varum. Just know that because NTA, common agency. Okay, look at how nicely it is done. This is Morbius rule actually, not Huckel's aromaticity, Morbius aromaticity. It's not in your syllabus except remember this molecule if it is printed. Let's look at examples, the best way to remember them. The chemical system that is non-aromatic. We know this is aromatic, this is the naphthalene aromatic. Okay, here this one is nothing but this is aromatic, but this is not aromatic. What is this? Basically, this is 7-membered ring, 5-membered ring. Okay, 7-membered ring la, didn't we see this? Remember? Sorry about the shape. Double bond, double bond. Okay, 1, 2, 3, 4, 5. Oops. Let's draw the 7-membered ring. So we can actually put it here. For example, 1, 2, 3, inge plus sign. Okay, here 2, inge minus sign, correct? View it as 5-membered ring this way, view it as 7-membered ring this way. Okay, so I'll clear it up and draw this again. So இது aromatic-ஆ இருக்கணும்னா cyclopentala உங்களுக்கு என்ன இருக்கணும்? மைனஸ் இருக்கணும். இதில் tropelium plus இருக்கணும். So when they are fused together, it is aromatic. Okay, That's how it is drawn. Similarly, this compound is extremely important. Now 5-membered ring aromatic இருக்கணும்னா 2 4 6 electron இருக்கணும். 2-membered ring 2 electron தான் இருக்கணும். So this electron can go here. If it goes, what do you get? இங்கே positive charge, இங்கே negative charge, correct? And cyclopentadienyl anion, okay, it's aromatic. Cyclopropane cation is aromatic. So this is good. How this is drawn? Inge positive, inge negative, inge positive போறதுக்கு பதிலா they can draw like this. Sorry, not this. Draw like this. So this is aromatic. In the ring aromatic, in the ring aromatic, because this double bond can donate. So again, this is all coming down to seeing these examples. Same examples keep getting repeated. The way the question is asked is different. This is for you guys to practice actually. Okay, I have given you the examples, answers itself here. This is for you to practice and look at the answers. Alright, this is the smallest lecture you have seen so far in organic chemistry, but this is nevertheless extremely important. Aromaticity, strong iron, all this might be new to you, but I can guarantee you these are the things that everybody is going to be comfortable sooner or later. How do you get comfortable and stronger? Practice. I'll send you a worksheet and also exams எழுதி தப்பு பண்ண you will start fixing it. As you fix, write your notes into better ones. Okay. All right. Thank you guys.